Today I will solve one question from CSIR Net December 2018 part B of linear algebra. Question is, let W1 is a subspace of R4 which satisfy these three conditions and W2 is a subspace of R4 which satisfy these conditions. Then which of the following is true? First is, these are the option. First option is about dimension of W1. So first we calculate dimension of W1. The vectors of W1 satisfy these three conditions. From second condition, we get that x is equal to minus 2v. When we put value of x in condition B or third condition, we get 2u plus 2w plus 2v is equal to 0. And after simplifying this, we get u plus v plus w is equal to 0. This is the same condition which we get from condition C or first condition. This implies third condition is redundant condition. We can occur third condition with the help of first and second. So we can directly eliminate this condition. This is of no use, or this doesn't affect the dimension of W1. So W1 contain all those vectors which satisfy first and second condition. So from here I get x is equal to minus 2u, and from here I get w is equal to minus u minus v. When I put value of x and w, I get this. And now there are only two variables u and v. When I write take u common, so this is write this vector, and then I take v as a vector and write this vector. This implies W1 contain all those vectors which are linear combination of these two vectors and both are linearly independent. So W1 is a span of these two vectors. So dimension of W1 is 2. But in option it is given that dimension of W1 is 1, but we get it 2. So first condition, first option is discarded. In next option it says about dimension of W2. So we calculate dimension of W2. W2 is a subspace which satisfy these three conditions. So from first and second condition we get u plus w is equal to minus x and u plus w is equal to minus 2x. U plus w is equal to this. This implies we can directly write x is equal to minus x is equal to 2x. So from here we get 3x is equal to 0, and from here I get x is equal to 0. Third condition says that v is equal to x, and from first and second I get x is equal to 0. So this implies v is equal to x is equal to 0. Now when I put the value of x in first condition, I get u plus w is equal to 0. From here I get w is equal to minus u. So W2 contain all those vectors such that first vector is u, second v is 0, w is equal to minus u, and x is equal to 0. So this is W2 is a subspace which can be generated with the help of only one vector. So W2 is a span of this single vector, and this implies dimension of W2 is 1. But in option it says that dimension of W2 is 2. So this implies second option is again discarded. Now in third option it's about dimension of W1 intersection W2. So we have the basis of W1. Basis of W1 are these two, and basis of W1 are these, and 2 are this. So it contain only one common vector. So their intersection can't be greater than 1 because W2 contain only one vector, and so in their intersection it is either 1 or 0. Dimension of W1 intersection W2 is either 0 or 1. So they have one common vector, so their intersection dimension of their intersection is equal to 1. And in option third it says that dimension of W1 intersection W2 is 1. So third option is correct option.